If, much like myself, you have been sat at home thinking to yourself, oh, I need some more Erics in my life, good news, folks, you are in luck. Your next speaker of the 2021 CityJS conference is Eric from Fremont in the USA. Eric is the Senior Developer Advocate with Couchbase, and this session is focused all around JSON data modeling. In this session, Eric will be comparing JSON data models with traditional relationship database models, as well as looking at how design decisions at this point impact your application's performance. Fantastic stuff. Wherever you are watching along at home, please do keep the comments rolling in. It's been great seeing everything that you've been thinking about the conference so far. And don't forget, keep posting along on social media using the hashtag CityJS2021. Eric, without further ado, it is over to you.
All right. Hello, CityJS. Hello, everyone in London and everyone joining remotely. My name is Eric BISHARD, and I'm a developer advocate for Couchbase, a document database company. Today, we're going to be talking about JSON data modeling for the document database world. So, on our agenda today, we're going to be talking about why NoSQL. Why would you choose a NoSQL database over a relational database? We'll talk about JSON data modeling, techniques, and rules of thumb. We'll touch a little bit on relational versus document schema. There are many talks and resources out there for that, so we won't spend too much time on it, but I will have some resources included on one of the last slides that I give you, where you can go and check out some different information on that topic. Also, we'll talk about document database relationships, and this is where we'll spend some real quality time. So, why NoSQL? So relational databases don't always handle change as well as a NoSQL database. And I'm talking about document databases in particular. We have a much more relaxed schema, and distributed document databases can handle scale, agility, and flexibility very, very well. And that's what we're going to talk about. Scalability, flexibility, and availability first. So with scalability and databases like Couchbase, the ability to scale is key. So we have clusters that are made up of many nodes that can easily be increased or decreased based on demand. So imagine that your system needs more demand for an event like Black Friday. Now, more nodes can be added to the cluster and can be configured or make changes itself to auto-distribute load, CPU, RAM, and disk space. So when it's needed, you can scale up, and when it's not, you can scale down. We provide a couple different ways of scaling. You can have one-dimensional scaling where the number of nodes on the cluster share the ability to run query, indexing, and data services. You also have multidimensional scaling where a single node on the cluster can handle, for instance, querying, another node can handle indexing or data. And of course, if you have more than 3 nodes, you can split up those services among however many nodes that you want in any different kind of configuration that you want. So, as far as minimum nodes for a Couchbase production deployment, we usually suggest 3. Most of the scaling actually, from a developer's perspective, happens behind the scenes. So it's not something that you really need to worry about when using the SDK and writing code against Couchbase. Now, when you add or reduce capacity as needed given the right configuration, you can scale up or scale down for events like I said, like a Black Friday event. You can scale up one at a time, you can scale up multiple nodes at a time. It's really up to you. Scaling up nodes will cause a rebalancing, and with a platform like Azure, you can literally use a slider to increase the number of nodes. In theory, you could scale up to 1,024, but I don't think anyone's ever gone that high. And then, of course, when you don't have that demand, you can scale right back down. One of the things I just wanted to touch on again is that when you have this multidimensional scaling, you could, for instance, have 3 nodes that each handle a different service. And then when you scale up, you can just scale up maybe the data or maybe the indexing or query services in particular. right? So you could continue to just have one query and one index node, and then as you scale up, you're just adding more nodes that take care of data. Flexibility. So we have flexibility in terms of schema. There's no rigid predefined schema. In a relational database, your data needs to fit into predetermined tables, columns, rows, and use exact data types. So in Couchbase and most document databases, every write can be a document of a different size and shape. If it conforms to JSON, it gets stored with a key that you provide. You can let your application define what shape your documents are stored as. And we kind of look at that as application first, document design. Availability. So high availability in a system like Couchbase is achieved by means of cross data center replication. We call it XDCR. Now, the contents of a bucket can be selectively replicated to a bucket maintained on like a remote cluster. We also have server group awareness that allows groups of nodes to be defined within the cluster to protect the cluster against failure. So let's talk about the NoSQL landscape and the different type of NoSQL databases that are out there. You've got key value, document, graph, and wide column. So, relational databases are great for answering known questions and are rigid by design. NoSQL databases can help you to answer questions that you didn't expect and allow for a more flexible schema. The line between key value and document databases is blurry at times. And as you can see, several databases here kind of fit into both of those categories. And there's other databases that even go further and can do key value, document, and graph. In the key value category, we have Couchbase, and some of the things that Couchbase as a document database is good for are things like caching. So you could use a Couchbase database, sort of like a Redis cache, in front of your relational database to do caching. You can also, as a document data store, use it for user profile management, content management, gaming, travel booking, fraud monitoring, and many other things. Now, when we're talking about relational versus document schema, sometimes there's a misconception that just because there is no formal schema doesn't mean that document databases are not structured. Okay, we have schema on read versus write. Any document can be stored, no matter what the shape is. As long as it's JSON, you can store it. So there's no schema on write. We do conform to schema on read, and that is more critical. Another thing that I would say is that when you're looking at a document database for your project, you need to understand the trade-offs of relational versus NoSQL databases. So before making your choice, you need to do your own research, due diligence, understand the trade-offs, and maybe consult a DBA, or if you would like, you can consult us. So when you're storing documents in a document database, one of the things that is probably the most important to understand about document modeling is what are embedded documents. So I like to say embedded documents are the curlies within the curlies. So as you see here, we have a little JSON document, and you've got the curlies on the outside, and that kind of has the entire document in it. And then for address, you have another set of curlies. So you have another object within an object. That's what I'm talking about when I say embedded documents. So JSON contains name value pairs, and here the address has an embedded object. So a whole nother set of properties inside of it. And the question is to embed or not to embed. And that's the question that we're going to try to answer. Some of the steadfast rules for embedding versus reference is to try to embed rather than reference, right? Reference a document. In other words, take that object out of that document and put it into another document when the parent document is too large. Maybe it exceeds the 20 megabyte limit. Now that can be very hard to do. A parent document may have a query that you normally call to look at that parent document. And if that address is never being used, then maybe you should put it into another document. But if it's always being used, then you should probably include it and go ahead and embed. Think about over the wire, right? If you are always making queries and you're getting back information that you don't need, maybe it shouldn't be in the document. So related data in another document will require a NQL query typically. So what is Nosql? Nosql is a query language. It's a variant of SQL, and it's our query language at Couchbase. So that's one of the great things if you do use Couchbase, is that you'll be able to use this query language that you already pretty much know if you have ever dealt with a SQL database before. All right, now we're going to get to actual document modeling. So the first thing we're going to talk about is embedded documents. And this is one of the more important topics to talk about when you're talking about modeling. The advantages to embedding a document. So here we have basically the curlies within the curlies. I like to say we have the red part of this document is the embedded document, right? It's an object within an object. So the address has a street, city, state, and zip. These different properties all wrapped up in an object. So JSON contains name value pairs, and here the address is embedded. And the question is to embed or not to embed. That's the questions that we're going to try to answer. Now, the advantages to embedding is that you can have a single atomic KV operation, a key value operation. You don't have to do any joins or nests. None of that is required in order to get this document. Now, if all the data is important to that document and for a majority of your reads, you should embed it. With a document database, you get to choose the level of normalization. Repeated data is not always bad in a document database, okay? So you can kind of choose whether you want to have repeated data or less repeated data. That's kind of a different level of normalization, and that's completely up to you. Now, disadvantages of having basically embedded documents is that documents can become large and lead to refactoring. So 20 megabytes is the limit in Couchbase. You're typically not going to reach that. So embedding is typically going to be very easily to do. Now, you could end up nesting a lot of subdocuments, which is another kind of disadvantage. And the reason why you might want to actually pull out an embedded document and put it into its own document. I typically think that if I have, for instance, address here had 3 different nested levels inside of it, that's a little bit too much. 2 is kind of where I start to draw the line. And so I don't think an address would typically have 2 nested objects, but you could have a nested object that has multiple nests 3 levels deep, and then you need to start thinking about, why do we have this? Why are there so many levels? And potentially, do you need all that information when you call this hotel, when you try to get this hotel? Probably not. Now, steadfast rules for embedding versus reference. Try to embed rather than reference. We already went over that. Reference documents when it's too large for the parent document, rarely is going to happen. I guess in a case of like a hotel, you might have thousands of reviews, right? You may not want to embed those inside the hotel document. Parent document queries, if they rarely use the information, think about putting it in its own document. Think about what's going over the wire. When you get that hotel, do you need to have the address? If not, you should probably put it in its own document. And then if you ever do need it, you can do a query and link them together. When you do related data, so when you put related data in another document, you're going to need to have a Nosql query in order to join them together. So Nosql is our query language at Couchbase. It's a variant of SQL. We'll talk about document relationships now, and we're going to talk about one-to-one, one-to-many, and many-to-many. So in a one-to-one relationship, the most simple type of one-to-one relationship is a primitive value, right? We have name here. The hotel name is Sheraton Agora Hills Hotel. That is the most simple type of one-to-one relationship. It's basically a key value pair. Next, we have the embedded document or the embedded object, which we already talked about. Address here has a street, city, state, and zip all wrapped up into one object. That's an embedded object inside of this document. Then we have the related document. So in the case where address is not always needed when you get your hotel, maybe you store the address in its own document by key, all right? And you reference it by key in the hotel document. Now, behind the scenes, if you were to do a Nosql join and write a piece of NQL statement that would actually go and join these two together. Basically behind the scenes, Couchbase knows that, the address, if you specify that the key for this address is in hotel.address, then it's going to know, it's going to take that number, it's going to go find the key that of the document that's related and join them together and present it to you as one result. Now, the NQL query. What does a NQL query look like? So NQL is N1QL, and that is our Couchbase query language, and it is a SQL variant. So how close is it to SQL? Well, let's take a look here at this join. Considering our related documents, this will return just one document, right? So it selects the hotel and address. It joins the address document on the key that is found inside the hotel's address property. It's that simple. And then we say where the document type equals hotel and the ID of the hotel is hotel 1000. And that will get us just that one hotel with the associated address. Next, we have here the resulting document. This is kind of what it looks like all put together. This is the same NQL query on the left-hand side here that we just saw. And on the right-hand side, we are seeing what the resulting document would look like, right? So normally this hotel has an address, which is basically just a number, a key to another document in the database. And here, when we use this NQL statement, we get a resulting document that has everything put together, right? So the join clause enables us to combine two or more documents. Next, we have the idea of a one-to-few relationship, which is exactly the same as the one I just showed you. So instead of, maybe we need two different addresses for each hotel, a main and a shipping address. Well, here in the hotel, we can just call it addresses instead of address. And then we can point to a single document which has both of those addresses in it. We use a very similar NQL statement here, and then our resulting document, very similar to what we saw before, except here we have an object with multiple objects inside of it, right? So that's what I call the one-to-few. Yeah, and then this one takes advantage of OnKeys, as we saw before. And this is a way that we can ensure that the joins take advantage of KV operations underneath the hood. So when you say OnKeys hotel addresses, it knows that the address that it's going to go look up by key is something that it can easily do underneath the hood with a KV operation, a key value operation. And it'll be very efficient. Next is the Ansi version of this same query. So basically, Ansi support means that it is more standard and not specific to Couchbase. Ansi also, the syntax supports outer joins. You can join any way that you want. So here we're joining by the actual key of the document, but you could also do field to field. You could use relational operations like equals, not equals, less than or equals to, more than or equals to. You could use the like keyword, just like in SQL. So from here on out, I will show you Ansi standard NQL examples, just to make sure that we're doing this the most standard way. Next, we have one-to-many relationships. And the first one we're going to look at is very simple. We have an embedded object. We have the concept here that we have a hotel document, and it has a reviews property, and its value is an array of reviews, which I don't show all the different reviews here. I have them condensed down with the three little dots here. But just imagine that these were review documents, and there were three of them. You could embed them all into one document, and that way it makes them very easy to fetch. You can just fetch the one document and get all the results back. You don't have to do any special joins or NQL statements or anything. In fact, this is all you would have to do if you were using the NodeJS SDK, is you would say const result equals collection.get. You would pass in the hotel key, and then you would get that entire hotel with all of its reviews returned back to you. So here we have, again, just a basic key value operation. By passing in the key, we get our document back. When we can, we want to use these types of KV operations instead of queries. By storing documents as one, we get the benefit out of not having to do any complex joins. I also went ahead and threw a couple more examples in here of what it looks like with the NodeJS SDK to do all the different CRUD KV operations, right? You've got a get, an insert, an upsert, a replace, and a remove. So the get and the remove, all you need is a key to either get a document or remove a document. But in order to insert one, upsert one, or replace a document, you need to have the key of the document and the document that you're going to either insert, upsert, or replace. Pretty easy, pretty simple syntax. So besides these examples, you can also read or mutate documents using another operation called lookup in or mutate in. And that way, if I wanted to, I could just go and just get the reviews of this document by doing a SubDocument operation. But I didn't put those here on the screen, but you could just know that that's possible as well. And it's just as efficient as a key value operation to get a SubDocument. Related documents. So that's the next type of one-to-many relationships. And here, same concept as before, we have reviews and we have an array of reviews. But instead of having each of the individual the review objects in here, we are providing just a key to go find another document, right? So typically when you would do this is in the case that we talked about before, when you have thousands of reviews maybe, right? And potentially you're concerned about if you were to store them all as objects inside of this document, that you may end up one day blowing past that 20 megabyte limit, right? That's a real consideration that might come up. This is just an idea here of what these reviews might look like, maybe on a very small scale. You've got a user ID, date, content, and maybe some ratings for the hotel, right? And then behind the scenes, if you want to do a nickel statement that will fetch all of these reviews for this hotel, you can kind of visualize it like this. Each of these IDs are going out to fetch another document in the database by key. Now, our query that for related documents like this, basically what we're doing here is we're selecting all the properties of the hotel. We're also getting reviews by review ID, where those review IDs are located inside of the hotel's reviews property. Pretty simple. Then we say, by document type hotel, and where the hotel type equals hotel 2000. And that'll get here the hotel 2000, and it will go and grab each one of those reviews, put it all together, and return it as one document. Now, many-to-many relationships, this is the last one we're going to go over. We have two different types of many-to-many relationships. We have bound and unbound. So in this example, we have the idea that an airport can have many airlines operating, and similarly, an airline can operate at many airports. So as we see on the right-hand side here, we have two different types of documents. We have an airport document, which has an array of airlines, and the airlines are all listed off by airline ID. Below that, we have an airline document where it has an array of airports, and all the airports are listed off by airport ID. So if we want to place a reference array on both sides of the relationship, not fearing an ever-increasing number of references that would exceed the size limit of the document, we can use this many-to-many bound case. Now, in order to query the airline with related airports, here is a nickel statement on the left-hand side. Basically, what we're doing here is we're selecting the airline and all of its properties. And then here, this array airport name, that is basically going to create an array of airports, actual names. So San Francisco International, Los Angeles National. And we're saying for airport and airports, it's just kind of like a loop syntax almost. And we are going to get from airline, so airline will be the parent document, and we're going to nest the airports by airport ID, where the ID is located inside of the airline's airports array. Got it? All right. Next, to reverse that around and do it the other way. Really nothing has changed here except for where the location of airport and airlines are inside of the query. But this is the exact same query in reverse to get a list of airlines that are associated with a particular airport. Finally, we have the many-to-many relationship, the unbound case. So again, airport can have many airlines, airline can have many airports. But in this case, let's say that we have a bunch of documents in our database, a bunch of airport and airline documents, and we want to create a relationship and not store it. We don't want to place a reference array on either side of the relationship, fearing an ever-increasing number of references would exceed the size limit of the document. We can use this many-to-many unbound case, okay? So how are we going to do this? How are we going to create the relationship? Well, what we're going to do is we're going to borrow from kind of the relational database, and we're going to use an associative, not a table, but an associative document, right? If you've worked with relational databases, you may know what an associative table is. Sometimes it's called a bridge table. Many different names for it out there. So here we have 1, 2, 3, 4, 5 different documents, and these are recording all of the different relationships between airports and airlines. So we call these associative documents, we're calling them the type of document, we're calling it airline_airport, just to give it a type, right? And we're gonna use that type kind of in our NQL statement that we'll see next. But basically, each one of these just says, hey, airport 1000 is associated with airline 3000, right? And what we're going to do here is create the same relationships that we saw in the previous example, but with these associative documents. Now, our NQL statement gets a little bit trickier here. But again, once you start writing these NQL statements, just like maybe you have in SQL in the past, it starts to become second nature. And this stuff, even if they get a little bit long, it makes perfect sense and they're not too hard to figure out. And what this NQL statement here will do is it's going to select airport name and aggregate basically in an array airline name as airlines. Okay, so basically the only thing we're getting from airport in this, the parent document is its name, and then we're going to create an array of airlines by name, right? From the airport, which is the parent document. We're going to join on that associative array where the airport ID equals airport ID. And then from there, we're going to join on the airline where the airline's key equals the associative array's airline ID, right? The rest of it's self-explanatory. We're kind of narrowing it down by telling it what the document types are: airport, airline, and airline airport. And then we're grouping them all by airline name. But what we get on the right-hand side is potentially exactly the way that we want to represent this document back to, maybe it's the API that's calling this query, right? We want to give it back the name of the airport and all of the airlines that are associated with it, right? So it's pretty cool. So that this way you can take these different documents in your database, and they've got these associative documents that are creating a relationship, and we're able to kind of take those and return back this new object that doesn't even exist in the database, but we've created through these relationships. So we group our airlines in an array as airlines, join on those airport and airline IDs by type of document from those associative documents. Now, this is the only query that we've shown so far that kind of needs its own index to be a little bit more performant. But so in able to create more advanced queries like this, you have to start learning a little bit about indexes. In Couchbase, the way you create an index is very similar in a relational database, right? In a relational database, you just use a piece of SQL, and here in Couchbase, you use a NQL statement. And all we're saying here is create an index with the name, the name in blue here, and then we're going to do that on our travel bucket. Remember, a bucket is just a bunch of documents. The travel bucket, in our case, houses all of the airlines, airports, hotels, and reviews, right? But this particular index is going to be on that travel bucket, and it's going to be of document type, airport ID, and airline ID. And with this very simple index, we will have a very efficient running query here. And this is called a secondary index. In particular, it's called a composite secondary index because it's on multiple types and IDs. All right, so Code samples, queries, and all resources I use for this talk can be found here at this tiny URL. I hope you check that out. Feel free to reach out to me on Twitter or email if you have any questions. If you want, at this address here, you can find a repo where I have all of the code required to add all of these documents to the database, to a Couchbase database, and then all of the code required to query them. And I also have one file in there that just has all of the Nosql examples that we saw. It has not only the Ansi versions, but also the kind of legacy versions that we have that are more specific to Couchbase. But I put, so there's even more Nosql queries in that document than I even showed in my slides, just to give you as many resources as possible. But that's all I have. Thank you very much for joining me in this talk today. Again, my name is Eric BISHARD. I'm a developer advocate at Couchbase. You can reach me here at my email or hit me up on Twitter at HTTPJunkie. Again, thank you very much and have a wonderful day, CityJS.
Eric, that was a brilliant talk. Thank you very much for delivering it as part of this year's CityJS conference. I'm sure our audience will be heading off shortly to introduce some extra flexibility to their JSON data structures. Really, really useful stuff. Thank you. I'm sure everybody at home is going to want to join me in giving you a huge round the world round of applause. If you have any questions for Eric about JSON data structures and the aforementioned flexibility, please do join us for the Q&A session, which will be starting on GatherTown any moment now, or post along on social media using the hashtag CityJS2020 or on YouTube in the comments section. We'll see you shortly for the next talk. Eric, what a fantastic talk. Thank you for delivering it as part of this year's conference. I'm sure you had a massive round the world round of applause, but here is your follow-up.
Thank you.
It's just around my porch rather than the world. Fantastic talk. And we've had a question come in already, so I'm going to dive straight into it and we'll see where this takes us. And this comes from Andre. Given the example with the hotel reviews, is there a way to build up a limit in N1QL?
Yeah, so I think I know what he's speaking about. So take the example that instead of reviews, maybe you have a Twitter account. And by the way, MongoDB is kind of a competitor, but you guys had a guy on, Joe Carlson, and I think he covers this exact topic in his talk. He has a similar type of talk to me at your conference. So I love the MongoDB guys. We're good friends with a lot of them. Check out his talk because I think it addresses this exactly. Say the fact that you have Twitter, you have people on Twitter, right? Some people have the blue check mark, some people don't. The people with the blue check mark typically have a lot more followers, sometimes in the millions, and rather than like the thousands, right? So, and if Twitter was using a document database behind the scenes to keep track of followers, just like we keep track of reviews for hotels, there may become a certain limit where very famous Twitter people have this exorbitant amount of followers, right? And it doesn't fit into the normal way that they keep track of followers in the similar way that we keep track of hotels in that example. So the point is that when they have this type of a user, or when they meet this limit, you can set a new attribute on the document in the Twitter example for the Twitter document that represents that person, that says there are special conditions here. And then what you can do is you can just start keeping track of those, I guess those followers in this case, in a different manner. And when you go to query that particular user, you see that they have this special attribute, and you query their followers in a different way. And that way you can keep track of as many as you want. And potentially, when you query users, you query regular users one way, and you query these special users in a different way. If that's not what he's asking, if he's just simply asking if there's a way to limit and the amount of results that you get back, which I don't think was what he was asking, but my answer to that, if that's the case, is just to use the limit keyword, just like you would in SQL. A lot of Nosql is just standard SQL. In fact, Nosql has basic Ansi SQL. So a lot of the things that you can do in SQL, you can do in Nosql. But that is more of a data management questions, and with a document database, you can pretty much do anything that you like. So building up to a limit, you would have to build some logic, probably into your database, and also construct your models a certain way. And you can do anything that you want. Like that's the thing about NoSQL databases and document databases in particular, are they're super flexible. So if you can dream it up, someone else has already done it out there. But my suggestion would be to watch the other talk from the MongoDB folks. I hope my boss doesn't hear this, but literally, I think he covers that exact question.
Okay. So your mention of MongoDB there leads me nicely into my next question. And this is for my benefit more than anybody else's. My experience of NoSQL databases is MongoDB or Firestore. Is Couchbase really that much different to those, or am I going to be able to pick it up with the knowledge I've already got and run with it?
No. So Mongo is very well suited to not only enterprise level applications, which they do very well, and they have a lot of the same features that we do. But there comes a time when certain companies need to scale beyond a certain point, and that is really where Couchbase shines. And I know it's a very cheap answer, like, oh, we scale better than some other databases do, but it's true. If you're running a very small blog application that only requires one node in a cluster, you probably shouldn't be using Couchbase. And not that that's the only thing that Mongo can do, because it can do a lot more, but that might be the right choice if you're a new developer to use Mongo for a smaller site. That doesn't mean that they can't scale very well, but at a certain point, the scales tip into to our advantage. When it comes to a company like LinkedIn for keeping track of profiles, profile stores and all of their users, right? They use us. When it comes to United Airlines and Amadeus for travel booking and millions of bookings per day back, when planes were actually flying. This type of scale warrants being able to have a database that can handle that scale. And then one of the other kind of benefits of Couchbase behind the scene, and that the developers really don't need to have to understand, is the ability to do cross data center replication. I touched a little bit about it in our talk. Failovers, having different clusters in different geographic areas of the world. So your database administration team can kind of set up all of that configuration to make sure that these things have a really good uptime, that there's good failover, that you're distributing the different services. Like we have query services, indexing services, analytics services, full text search services. And as you build out your cluster, each of those nodes can either work on all of those services, evenly, or you can say, hey, I want this node and this node and this node to do these things, and then I want these nodes to do something else. And then when I scale up, maybe I just scale up these few services and the nodes that run those services, and I leave indexing alone, right? So you can do multi-dimensional scaling, regular scaling, but from a developer standpoint, the person who's using the SDK to write the code in the JavaScript application, this stuff really doesn't matter to them. But yeah, we scale well, and I think that was in my talk.
I think that's a relevant answer to the people watching this. The people who are at this conference more often than not are working with enterprise level applications. So
yeah,
I mean, you say that's the cop-out answer in your different words, but I think it's the perfect answer, really.
One of the things I would say there is think about it. If you are someone who has been working in this industry for a long time, maybe you started out with MySQL databases, and then eventually you moved to a company with a much larger operation, and they were using like MS SQL or PostgreSQL, right? The advantage the advantage of knowing those other database technologies, even if you're not using them all the time, could potentially pay off down the line in your career as a developer. So what I always say is, if you're checking out NoSQL databases, it behooves you to not only check out the databases that are very friendly to new developers, like Mongo and like DynamoDB, which if you're working with AWS, you probably used before, Cosmos for Azure, but also to be looking at these other more enterprise level document databases, understanding at least the basics of how they work. Because those even though we're not the most well-known database out there, the people that understand how to use our technology, they get paid very well, because still we are a unique database, right? So and it's not much of a stretch to jump from one of these other document databases. Everything you know about JSON data modeling ports over, right? If you're coming from a relational database world, we use a SQL-like query language. There's a few other databases that do it like us, but we are the one that has really made it popular, and we use Ansi SQL. So it's a standard SQL. So 90% of what you know from SQL, when you come over to Couchbase, it already works. Some people say it's weird to like, oh, you're using SQL in your document database, and that sets up in people's minds that they should be thinking about doing things in a relational way in a document database. And I think that's silly to think of that. The only thing that our query language is doing is capitalizing on the information that you already know from working with SQL. But when it comes down to data modeling and structuring your data, it's no different than any other document database, and you shouldn't be thinking in a relational mindset. You should be thinking in a scalable, flexible document key value store mindset.
Brilliant answer. Brilliant answer. So we've only got a couple of minutes left. So
Sure.
Quick answer for this next one. We've got 2 minutes, in fact. I see a keyboard next to you. What type of music do you play, my friend?
Electronic music.
Electronic music. Is there any of it out there in the ether that we can go and check out, or is it closely guarded?
No, I have a SoundCloud account, Jack Mono. That was my cat's name back in the day. And I didn't put anything up for 8 years. And this last few months, I put a few things up. So I'm getting back into it. I moved into a house where I have a nice office now, and I decided break out the keyboard. I wish I still had my turntables and everything. That would be nice. So I used to be a DJ back in the day, when I was really young, back in 99, 2000. But yeah, just trying to get back into those things, video editing. I went to school for digital media. So video editing and music production, I've always been very into. I've been doing it for a long time. And I took a break from it to move out here to California, take a tech job, and better my career. And now that I'm at a point where I can take some time off to do these things, it's a great way to get away from code.
Yeah, it really is. And it's a creative endeavor, which I think a lot of people have discovered over the last 12 months, that they actually have creative juices in there, which is just wanting to get out. And sounds like that's been right for you. I am definitely checking that out. Jack Mono, you said.
Yeah, now it's out there. Great.
Put it in the chat, put it out on Twitter, everybody. Let's get the whole world on Jack Mono.
Yeah.
Eric, my final couple of questions for you are super rapid fire. Tabs or spaces?
Tabs.
People keep choosing the wrong one. Front end or back end?
Oh, that's tough for me. So both.
Full stack. I like it. And finally, bananas or apples?
Apples for sure. But I do love bananas. And by the way, you've never had a good apple unless you've been to like the Netherlands.
Okay, so
that's
maybe
where the good apples are.
Conferences in Netherlands, put some apples on your plate, and Eric will happily come and talk for you.
Yeah, and if you come out here, I'll give you some avocados. So
look at that, fair exchange. Eric, it's been a pleasure catching up with you. Thank you very much for your talk this year. I'm sure everybody took a lot away from it. If you are watching along at home, don't forget to go and visit those sponsor booths and win yourself some prizes. There are still some amazing things out there. But once again, Eric, thank you very much for being part of this year's online conference.
Sure. Thank you very much. Have a good one.